Hello, and welcome to the session on creating a DevOps toolchain with Spira and TaraVault. My name is Adam Sandman, and I'll be presenting this session today. In this session, we're going to be looking at DevOps, defining what it is, and then looking how you can put an end-to-end toolchain in place using both Spira from Inflectra, but also other tools, both open source and commercial, tools like Jenkins, Git, Amazon Web Services, using unit test frameworks, and then tying in automation tools like RemoteLaunch and Rapise. We're also going to be talking about how you can incorporate automated packaging, deployment, testing, and monitoring as part of the CI and CD process. So first of all, what is DevOps? It's a good question. So DevOps really came about because with the Agile methodology and the Agile approaches, things like Scrum and extreme programming and Kanban, you've basically accelerated development and testing so that you can deliver software faster. You can develop it faster, you can test it faster. The problem is the IT and operations side of things hadn't yet caught up with the Agile revolution. And then as tools like clouds, containers, and other IT infrastructure that lets you deploy things and provision systems and servers and infrastructure faster and more nimbly than before became available, infrastructure now was able to respond at the speed of Agile development. And that's what DevOps is. It's making the operations side as fast and integrated into the Agile process as the development side and testing is. And if you look at the infinity diagram and infinity loop on the slide, that's how it's often represented. It's continuous delivery of business value to an end user, creating something, verifying it, packaging it, deploying it, releasing it, configuring it, monitoring it, and then what comes out of that is then put back into the cycle. Feedback from users goes into the plan that then creates new functionality and so on. So there's this continuous cycle of delivering business value to your end users. Now, the left-hand side has a slightly different diagram, which is less common. And this, I think, is because people, when they think of DevOps, they think, where's the testing? I develop the code, I release it, and the users do the testing, which is absolutely not DevOps. DevOps should be integrated testing. So testing is an equal part of the circle. There's three kind of overlapping circles in the Venn diagram that gives you DevOps. So some people call it DevTestOps or DevSecOps, and all these other, portmanteaus become available, but that's not true. It is just DevOps, but testing is embedded throughout that entire cycle. So let's look at each of these elements of DevOps in turn. And in this session, we will be focusing on using the Inflectra toolset plus a lot of the tools that we integrate with to satisfy this DevOps infinity loop. So first of all, let's talk about planning. Without planning, you can't deliver anything. And as they always say, if you fail to plan, you plan to fail. Planning really consists of two things. First of all, it's actually defining what you want to do and then planning how you're going to do it. So defining means coming up with things like requirements, understanding a common language about what is it the functionality we intend to deliver, how will the users experience it. They sometimes call requirements or user stories, the different definitions of it. And then planning is taking those ideas, requirements, and concepts and saying, well, when are we going to be delivering it? In what order? Which functionality comes first? Are the dependencies? All that kind of stuff. But basically, planning out when it will be released and realizing that business value, on a particular schedule. So planning takes the what and focuses on kind of the when and the how. So within Spira, you typically do the first part, the definition, in the requirements definition part of Spira. So you go to planning requirements, and there's different views within Spira to support the defining of requirements. This is your classic tree view, where you can see all the requirements in a tree structure, together with the tests that are going to be going with it, the priority, the status, the progress of the tasks, the progress of the testing. So you can see all the functionality, and oftentimes you'll think of an idea, let's say it's going to be adding a new feature. You can then decompose that into smaller ideas. We're going to create a new login page. Well, can you log in with a login and password? Do you use two-factor authentication? You decompose an idea into smaller pieces so that you can really understand how you'll do something. The danger is if you just define it at a very high level without breaking down to small elements, it becomes untestable. So it's really breaking something down to the point where a user can say, I understand how it's going to work, and a tester can say, I understand how I can test it. Other times you want to be able to see things in more detail than just that tree view. So Spira has a document view. A lot of times, if you're dealing with large, complex systems, particularly those working in regulated environments, the requirements aren't just how the system will work, but also the contextual environment in which the system operates. So, are there any legal rules? Are there any policy definitions? If you're working in the insurance space, if you're building a claims management system, there are rules about how insurance works legally. If you're working in banking, there's various banking regulations. In healthcare, there's lots and lots of regulations, of course. So requirements aren't just the system's features, but it's also the statutory requirements that you have to work within. So having a document-style view of the same data can be very useful when a requirement is more than just the system must do X and Y, but it's also, according to the law, it has to work in this specific way. Other thing you might find is that requirements are not always best described in a textual manner. Sometimes it's easier to understand as a process flow. The user logs into the system, they choose an option, they do something. You can write that, but putting it into a process flow can be clearer. You can also attach documents and diagrams and other things that will help illustrate a feature or requirement in more detail. But Spira has these different views to make it easier to define things in different ways. Another part of defining something is what is the relationships between the different items. And sometimes it's hard to visualize in text, so Spira does provide you with a nice tree view in the mind map view where you can see all of your requirements broken down successively into smaller elements, and you can include associations if you wish to show any relationships between requirements and dependencies as well. Okay, another way of thinking about requirements would be, well, what are all these features and how do they break down? So another way of thinking of requirements on a more agile project would be a storyboard. So in Spira, you have a backlog, which is the exact same set of requirements we saw before, but now it's shown in a storyboard form with the name of the user stories, the description of the user story, which is like the long name. And in this case, it's being shown by component. You can also show it by the tree structure, by the epic priority. So there's lots of different ways of seeing these requirements within Spira, but it is the same information. So what you saw in that document view that your business analyst might want is the exact same information that the project team is going to see in the storyboard. You aren't managing 3 different tools. You're just having 3 different views of the exact same data. So it ensures there's a common understanding of the requirements. And that's what we mean by requirements definition. Of course, requirements are only good as the plan. And so once you've got the requirements, you will then typically take those requirements, break them down into very discrete tasks, and then assign the task to the developers, testers, the IT personnel. If you're provisioning Amazon instances that they'll be deploying on, or containers, you might have IT management tasks that have to be put in place. There's development tasks, there could be setup tasks, all of that sort of thing. So in the system, each of those requirements and user stories will be broken down into several different tasks that are assigned to different people. And then Spira lets you track each of the tasks to completion. And then as each of the tasks gets done, it rolls up that status to each of the requirements, which then rolls up to the parent requirements. So you can always see how close to done are we truly. So that's some of the planning side of things, which is to take requirements and stories and other forms of the definition and putting it into a plan. Okay, so we've now got a list of requirements. We prioritize them. We've got tasks to define the activities. We've got to build some functionality. How do we do that? So we code. Okay, and we do that usually in a tool called an IDE, or Integrated Development Environment. The screenshot I have here is Visual Studio Code. There's various different tools, for example, Visual Studio, Eclipse, Java, it has IntelliJ, there's PHP Storm, there's plenty of tools for JavaScript projects. So you're basically going to write code. Spira does come with some helping features for that. First of all, many of the IDEs that you'll use, for example, the ones I've mentioned, that we do have a plugin for all of those. So you can see, as you can see on the right here, a list of all your work. So the developer doesn't have to alt-tab between the coding tool where they write their code and fix the bugs or implement the features, and Spira where they're going to see what work they have to do. The plan is embedded right there inside the IDE, which is really nice. So that way you can very easily see, what do I have to work on? What code am I writing? And you can even drag and drop those items into the code to associate it. So when you commit the code, which we'll talk about in a minute, it actually commits it back into the source code with those associations. So simplifying the code to commit and tying it together. So how do you manage code? Well, you manage code in a source code management system. Here's an example repository. Inside of Spira, we have the ability to connect to different source code management tools. The 2 most common ones would be Git and Subversion, in this case, mostly Git these days. We can connect to those 2, plus a bunch of other ones. If you're using our cloud platform, we also provide the ability to host Subversion and Git for you in TaraVault. TaraVault is basically a cloud-hosted Git and Subversion repository system. You can also use other options like GitHub or Bitbucket as well. And when you manage the code, you're going to break it down into branches and feature branches, and there's different philosophies and approaches. I have another session during ICON that you can look at talking about different strategies for code management. So I'm not going to spend too much time on it right now, but there's different ways of managing code. But you can see all the code and all the revisions and all the branches directly in Spira, and you can tie it back to the requirements and the test cases and the tasks. So all that code is in there. Great. We've got to build the code. You can build it yourself locally, but that's not the way things are done anymore. With Agile, one of the key philosophies is if we're going to build and test, we should be doing it all the time. So the idea of continuous building and continuous testing is really important to Agile. It's one of the key tenets, actually. So you don't simply have developers build code on their machines and use that as a reference point. As soon as code is compiled, it's pushed into the repository, and then you have a tool called a CI tool or continuous integration tool or build server that's going to be taking all those changes from all the different developers and all the different teams that work on the same repository, compiling it and running any other actions, that packaging and testing it, which we'll talk about later. We're doing it on a repeated basis. In this example, we're looking here at Jenkins, which is a very common tool for doing that. There's plenty of other tools out there like TeamCity, Bamboo, Microsoft Azure DevOps has got pipelines now. There's many different tools that do CI. So you use your favorite CI tool. Spira does come with plugins for most of them. So we have plugins for Jenkins, Hudson, Bamboo, TeamCity, Azure DevOps pipelines, and some others we're working on as well. So that way you can build the code using the CI tool, which runs all the time, compiles the code, and reports back then into Spira. Did it pass? Did it fail? So you have a record in Spira of each of the builds tied to different releases and different sprints. There's also the option to trigger test automation if a build passes as well, which is another nice feature. But that way within Spira, you're going to have a record of all the builds going on. So okay, so we built our code, we compiled it, it's on the machine, it's the CI machines. Great, we have a record in Spira. We have to test it as well. So how do we test things? Well, this is the classic, they call it the testing pyramid. And the idea of the testing pyramid is, especially when you talk about automated testing, and that's what I'm going to focus on here, that certain parts of the application are easier to test and cheaper to test. And the idea is, you shouldn't just simply build an application and give it to a user or even an automated testing tool and say, test the user interface. You can do that. The problem is it's very hard and slow to test the user interface. The UI will change the most frequently and will therefore break the test the most frequently. So it's very expensive to create tests that way and to maintain them, more importantly. So we recommend, and this is an industry best practice, that you test as much as you can at the unit level. So every code function should have a unit test that tests it properly. Properly meaning not just happy path. Then you should look at all your APIs and service endpoints and have tests for those. And then lastly, for the things that you can't cover, which might be the UI layer, once you know you've covered all your unit tests, all your functions are tested, all the business layer is tested, all your API endpoints, all your AJAX services are tested, at that point, you now know that you've got a pretty reliable system if everything's passing. Now you should do the UI testing. And because you're testing those other layers more consistently, automatically, the amount of UI testing you have to do is much less, so it's going to be much cheaper. And if you do have to change the UI frequently, you don't have to do as much automation at that level. But you still should automate at that level too. The other thing we think about is what I call the hierarchy of testing risk, which is there's no point testing your application on a slow 4G network running IE 9 or 10 or 11, which is maybe the lowest browser you support, if it's not going to work on a fast network running on Chrome. Same thing if you're going to test a happy path and that fails, don't bother testing all the complex scenarios then until you know that passes. Because you can do all that testing, but the reality is you're going to fail a lot of time. And if the login page is broken and it doesn't work on any of the browsers, there's no point testing 10 browsers and testing other parts of the app. So basically what we would say is look at the testing risk hierarchy as well. First of all, have your test run on the happy path scenario on a safe environment, i.e. high bandwidth, known good browser, maybe the one that was developed for or developed on, and make sure that works. If that works, now try more difficult scenarios, but still use fast network and the best browser. Then you can start to look at the edge cases, the really difficult scenarios, maybe still use a safe environment. And only when you've done that and those all work, now you can invest the time to test across all the browsers, all the versions of the operating system or the database system, and then all the networking environments you have to support. At that point, mobile testing and so on. At that point, it's worth doing that. But otherwise, you could spend weeks and weeks testing with all these different cases, and there's a very simple bug that you have to fix. As soon as you fix that, you have to retest everything again. So it simplifies and saves time. Okay, so we've got a hierarchy of risk, we've got a hierarchy of testing. So the first thing we said is you should always do unit testing. And if you don't do unit testing, so back here, there's no point in continuing. So how do we do unit testing? Well, there are plenty of frameworks out there. The most popular is called the xUnit framework. That's basically the JUnit, NUnit, Python unit, all the unit tests that part of the xUnit family of unit test frameworks. Some languages have other options as well. So if you're using .NET, for example, you could use MS Test from Microsoft. You can use NUnit. If you're using Java, there's JUnit, but there's also TestNG. For JavaScript, there's a whole bunch of options like Mocha, Jasmine, Jest. For Python, you've got PyTest or PyUnit. Ruby, I think there's only one. So there's different languages, different options. Choose the unit test framework that makes sense for your language. Use the best practices. And of course, the great thing is Spira is enabled with plugins for all of these different options. So that's great. Choose your favorite. Enable the Spira integration. When your CI tool is running, the building, you can even have that CI tool like Jenkins run all your unit tests as part of the pipeline. That way, all the results will go back automatically into Spira. Okay, next, you want to test the service layer. How would you do that? Well, use a tool. There's plenty of tools that can do that. You could do it all in code using Visual Studio or Java and Eclipse or IntelliJ, and same as your unit tests. And that's definitely an option. And we do that for some of our code as well. In other cases, it may be more efficient to use a tool like Postman or SoapUI or Rapise, which is our tool. Whatever tools you use, test all of your APIs, all of the versions, all of the endpoints. Make sure you're testing negative and positive cases, fuzzing the data if necessary. And we do have plugins for those as well. If you're using Rapise, we obviously have built-in integration with Spira. If you're using a third-party tool like SoapUI, we do have a plugin for that as well. If you're doing it in code, you can use the same unit test plugins that you'd be using for the unit tests. But either way, make sure you're testing your unit tests, also all your API and endpoints. And again, like we said before, manage the risk. If your unit tests fail, probably isn't worth running the API tests in the pipeline. So make your pipeline exit early. The important thing about pipelines and build is, in DevOps, speed is important. If the build fails at the unit test layer, the build should just stop. Don't bother running the API tests. Don't bother running the unit test, the UI test. There's no point. So that's a good time saver as well. Okay, so now we've tested the APIs, the unit test level is good. We now should do UI testing. And we recommend you do both automated tests and manual tests. You can't automate everything, and manual tests aren't the best at everything either. For automated testing, there's a screenshot there of Rapise, which is our automated testing tool. We've got sessions at Icon about that, so feel free to go to one of the Rapise talks. They've got a lot of talks on automated UI testing, from simple applications to very complex data-driven business apps like Dynamics. It's a whole industry. It's very, very interesting though, but you can automate a large part of your application, but you shouldn't necessarily automate all of your application. And why? Well, if you've got an application that's going to be changing, the UI is being adapted, user feedback's coming in, the problem is you might take a week to write the automated tests. Well, the UI changes and those tests need to be rewritten. So you may spend more time writing tests and then time saved. So if there's parts of the app that are stable, like logging in, going to the navigation bar, logging in with different users and checking the navigation bar, that could be a huge time with different browsers. That could be a huge time saver. And if that's all you automate, that might be sufficient. Manual tests can be then used to cover the rest. So things that are in a high degree of flux and change or require a lot of subjectivity, have your users test them. And if you're going to have a lot of stuff that's very rote, repetitive, logging in with 1,000 users to test the navigation works correctly, that's a great candidate for automation. So use the two. And Spira has within it manual testing capabilities, and the manual testing is available both from a sort of more traditional scripted type of test or exploratory testing. And we have a capture tool called Spira Capture that lets you automatically put screenshots into Spira to make it even easier to do exploratory testing. Okay, so now you've got your application. It's been built, it's been coded, it's been tested, hopefully, and hopefully passes. We now need to deploy that and package it up. So packaging is a key portion of the DevOps toolchain. Packaging, to be able to see what needs to be packaged, we do have tools within Spira to help you out. We have the artifact repository where you can see all of the requirements and test cases. You can see how that links to all of the revisions and code changes. So when you have a particular branch in Spira, you can see which items that branch was fixing or which features it was implementing. So for example, we use that to generate the release notes when we release a new version of Spira. If you're going to release a new requirement in a release, you can see all the revisions and all the code changes and all the branches that have to be in that. So you can use Spira as your reference for automation of your packaging as well. Now, how do you do the deployment? This is the stuff that's a little bit outside of Spira itself, but it's worth knowing about. How do you deploy? Well, traditionally, when we first started releasing Spira in the cloud, we would release it as a physical download that you install on your machines, and you got a Windows server or a Linux server if it was another application, and you install it, deploy it, manage it all yourself on a physical operating system. That's how things were. We've now gone virtual, and what that means is instead of deploying it onto a physical server, it might be a virtual server that you host yourself, like VMware, and that was where you have virtual machines. So there's a host operating system, which is the VMware server, and then it has the various client operating systems like Windows or Linux, and those are running on virtualized hardware. So you can copy and snapshot the machine, you can spin them up really, really easily. So it really simplifies deployment. It's really good for testing as well. If you're going to have test environments, you can create them and tear them down really fast. So for example, we do a lot of testing for Spira itself on Amazon Web Services. We don't use VMware anymore. We've gone to the cloud. So we're now using EC2, Electronic Cloud Compute. We can spin up a Windows instance in 10 minutes or less. You can do it in code using REST APIs and have it run in seconds. I mean, there's lots of ways of doing it, but you can spin up Windows or Linux or other instances really quickly. You can deploy your application onto it, do the testing, and then tear it down. For production environments, all of our cloud instances of Spira now run on EC2. So we spin up a new environment when we need machines, when we have another client coming on board, and we can automate all of that. So it's been really efficient. It really streamlines the management of everything. The next level down, of course, is containers. Now, why would you want containers? Well, the problem is you'll have a lot of repeated infrastructure. Every time you spin up a virtual machine, you're spinning up a whole operating system, which is designed to host an entire machine, but you're basically doing it virtually. So the idea for containers was if we take the application and the application services and we separate that from the operating system itself, we can streamline everything and have what are called containers, which is basically just the application, just the infrastructure that application needs and the services that go with it. And that runs in the container versus having to have a whole operating system. So now you can spin up and tear down things even faster. You don't have to instantiate Windows or a whole Linux environment. So these containers allow you to deploy things on scale. You can scale really fast, really wide, and tear down really fast. So whatever method you're going to use, figure out how do you deploy your application. Is it an application that people have to download onto a physical server still? Is it something that's running in the cloud? Is it running in the cloud on a virtualized OS? Or have you gone to containers? Let's see what's right for you. And again, different options then depending what you have. You could have a traditional installer for a physical environment. You could ship someone a machine image that they deploy. You can give them container images. It could be SaaS where the user isn't really aware of what's going on behind the scenes. Or maybe it's actually a plugin. Maybe all you're deploying is a Google Chrome plugin or a Google Suite plugin or an Amazon or a Microsoft plugin or an AWS marketplace. There's lots of different options for packaging these days. And in many cases, a plugin is actually just a zip file with a different file extension. If you use any browser extensions or any like Google Suites and things, it's often a bunch of JavaScript files in a zip file. So it may sound magic, but it's often quite mundane behind the scenes. But just whatever you can do to automate it is really cool. If you can automate that creation of a zip file and renaming and uploading, if you can automatically create your images and post them to a marketplace, automate as much of the DevOps pipeline as you can. And that includes the packaging if it's possible. Okay, so we've got a packaging done. Now we release. Great. So what do you do when you release software? Well, you have to release the software. Once it's released, you need to make sure you know which version someone is using. And if people find issues, which they will do, how do you manage the change of those versions? And how do you deploy the changes based on the feedback and the changes and the change requests that come in? And how do you know which version someone's on and make sure you deploy the right version to the right person in the right way? That's the whole release management piece, different pieces of it. So within Spira, we help you in that. We can track all the major versions, we can track all the minor versions and all the sprints, and all that can be tracked within Spira. You can track, for every given release, you can track the progress of its development, to track the progress of its testing. We've also added functionality within the TaraVault part of the system. You can now track which servers it's integrated on, and even which servers it's deployed on. So if you're using Jenkins, for example, to do CI and CD, you can look at every requirement in the system and see where it was built, where it was deployed, as well. So we do let you have visibility into the DevOps toolchain from each requirement. From a configuration management standpoint, we do have versioning within Spira, so everything is versioned. We do have baselining support, and there's another session at this conference on baselining. But basically, configuration management is a whole topic to itself, like knowing what version of something someone has, what version of the system they have, what version of a particular requirement they're using. Baseline management within Spira makes that really easy. So you can see they're using 6.0.0.1 of your system. You know what functionality they have. They're using 6.0.0.2. Another thing is also, we can also version all the documentation that goes with it. So if you're working in life sciences or other regulated industries, configuration management doesn't just apply to the code, which is done in, say, TaraVault or Git. It is also done for the documents. So if you have to manage all your documents, Spira includes centralized document management, configuration management. So if you have user manuals or other diagrams or other documents that are managed in Spira, all the requirements can be linked to that document, and then you can track and manage all the versions, and you can use the workflow in Spira to make sure you've got a consistent set of documentation. Similarly for change management, how do you manage all the change requests? Spira can do this itself. It's got a change management workflow built in. If you go into the incident tracker, you can create change management types. You can have dedicated workflows for bug management, change management, enhancement management, issue tracking, risk management as well. So we can track all the changes to a particular requirement in Spira. You can then create requirements from those changes. You can track the changes. And again, when you commit the source code, we have a change come in. We're going to use that same feature we saw in the IDE. You can track that issue and that change request back to the code that was changed and why it was changed. So you do have traceability for every change that's made. One thing about change management as well is within change management that we have different workflows you can set up, and permissions and rules and electronic signatures. So if you want to have a signature when you change a system, we have the ability to have electronic signatures so you can see who signed off on that change and why it was changed. So again, release management is a really complicated topic. Spira gives you a lot of functionality for that, for managing the changes, the releases, the requirements that were changed, the documentation, the code. All of that can be managed within Spira. The actual releasing of the code itself is typically done outside of Spira using a deployment tool, and it can be automated or manual, but you can have visibility in Spira to that. Okay, next, configuration. So configuring your infrastructure. Now, this is not something that Spira necessarily helps you with directly. You do have the ability to track automation hosts. You can track the infrastructure in the tools. But a lot of this is done outside of Spira, but we do have integration with some of the tools that make this happen. Just decide how you're going to do it. Do you have fixed infrastructure, or you deploy to a standardized set of services? Do you use infrastructure as a service like Amazon? So we, for example, have AWS as our primary infrastructure, and we have a set of standardized AMIs that we use. So every client in the world is using the same AMI image for example, the web servers, for the database servers. So that way we can patch and update very easily. It's all configured. If you want to go one level further, you can even do it in code. You can use REST APIs in something like AWS so that you can actually have your code actually configure your instances. And if you want to change your configuration, you can have a JSON file or a YAML file, change the configuration. So lots of automation options. And you can even use Rapise to trigger that too. So monitoring. This is the part that's often forgotten about in DevOps, and it's one of the most important parts at the end, which is once you go live, you're not done. In fact, maybe it's just beginning. And there's different kinds of monitoring. There's monitoring the functionality, there's monitoring the performance, and monitoring the security. And that's just the system monitoring. We'll talk about business monitoring next. But system monitoring is the system functional? Is it up and running? So Amazon, for example, and Microsoft Azure, they have lots of tools for managing and monitoring. Is the system up? Is it performing according to the way it should? Did a server go down? Did an instance go down? Similarly, within your code, you should have monitoring within your code to see, are all the features working correctly? Are some features down? Do you have the ability to roll back to a different version? Can you roll back to a different patch from your configuration tool? Performance. Well, the system might be up, but the performance is bad. There are tools like Dynatrace that you can use to connect to, which will actually do monitoring. And having that performance monitoring tie back into Spira can be really useful. And then lastly, security monitoring. And that's a whole separate topic, which is outside of the scope of this presentation. But security monitoring is really important. You can put security into your DevOps pipeline in terms of the dev and test side, so you can check for vulnerabilities before you release the software. You should be doing that, of course. But also, once you go live, there are things in production you can't take for granted. Just because it was past security testing in development, maybe there's a different version of the server being used. Maybe there's a vulnerability in TLS that you didn't detect because your dev environment's different, the networking is different. Always have security monitoring in production as well as whatever you've done in the dev side. And again, there are lots of tools that do that, both open source and commercial. Another thing that we find very important, which people forget though, is also business monitoring. That means don't just wait to see if the system's gone down, but you may have business metrics that you're checking. So for example, for us as a company, we check revenue, we check conversions, people signing up for trials of our product. If that starts to drop off, if we suddenly see that one product, for example, no one signed up for, and that's not typical, we might find that our website's broken, that one of the products, product pickers is broken. Now, obviously, you really want to catch it before it impacts the business. But a second line of defense would be, if your system monitoring isn't picking something up, have your business users report things to you. Empower them to be testers. They can report back if something goes down. Especially with DevOps, where you're moving code into production faster than ever before, sometimes things will slip through the cracks. And having business monitoring and business trends and having maybe an AI system track, some abnormal event happens, this is outside of the normal behavior of our business. Maybe something's going on with one of our systems. So don't just rely on system monitoring, empower business monitoring. And then the last thing is user monitoring. This is our help desk tool that we use, your desk. Your customer support people will suddenly know. If something stops working, maybe a third-party app goes down, you're gonna see help desk tickets about it. And your help desk will be able to be a great funnel of, we're seeing a lot of tickets about, say, Jira integration, we get this, or Azure DevOps integration, which we see also. And when that happens, we'll have our customer support people come back to our dev team and actually say, listen, I've seen an uptick in the number of Jira tickets. What's going on here? And maybe it's just because it's very popular, there's a new version come out of Jira or something, or maybe there's a breaking change that Atlassian released, they didn't communicate well, and we realize that we have to make some changes quickly. So user monitoring of your users and your customers and your help desk and your customer support personnel, they are a testing part of the monitoring function too. So make sure that your support function of your business is fully tied into your DevOps pipeline. Don't have them in a separate room, completely isolated. They need to be part of your process, because not only will you find problems, which of course is important, but you'll also get good ideas for feedback, to feed back into the plan and defining. Someone who's complaining to a user that they're finding the system hard to use, it might not be a problem, but it might be an opportunity to improve the usability. Or maybe they complain about something, or maybe it's positive feedback. Oh, we love using your tool. It's so much easier than your competitor's tool. Maybe you need to tell your marketing team, but maybe it can inspire you to make the functionality even better. So leverage the benefit of user feedback real time from your support. So just to wrap up this session, Agile methods and cloud computing provide lots of opportunities to deploy things faster, easier, and better than ever before. And DevOps lets you streamline both the infrastructure and the development and testing, from coming up with an idea in your head, pushing it through the pipeline, having it deployed, having it be available faster than ever. From the idea to release could be potentially hours or days instead of months or years. However, every company is different. If you work in a different industry, you may have to tailor your pipeline. If you're working in life sciences or insurance, you probably can't release to production every hour. If you're working in media or consumer products, maybe you can. But even so, you can still benefit from the efficiencies and the feedback cycle that comes with DevOps. Just make sure you tailor your process to your industry, your business model.